In this video, I'm going to go through CC17, which is the atmosphere. It's also a paper 2 topic. When we're talking about the atmosphere, we're talking about the blanket of gases that surrounds us on Earth. So in any room, you've got nitrogen, you've got oxygen, you've got a small amount of carbon dioxide. Those gases that surround us make up the atmosphere. The atmosphere that we have today, however, is very different from what it would have been on early Earth. Early Earth, the atmosphere was made up of mostly carbon dioxide and water vapor, whereas now we've got mostly nitrogen, we've got around 21% oxygen, and we've got a very small amount of CO2. So you need to look at what caused the composition of the atmosphere and what caused those changes. So if we go to the early atmosphere, it was incredibly hot. And because it was so hot, more than 100 degrees Celsius, any water that was present as water vapor instead of liquid water. So there would be no liquid water at all present on Earth. All of it was present in the atmosphere as water vapor. The other thing to know about the early Earth is that we had a lot of volcanoes, and volcanoes produce a lot of CO2. So the reason the early Earth was mostly CO2 was because of all of those volcanoes producing that CO2. And again, the reason there was so much water vapor in the air was because of the high temperatures meant all water was present as water vapor. If we look at the modern atmosphere, you can see it's quite different, and you need to know how that atmosphere changed and why it changed. So the first thing that would have happened is that the Earth cooled. And when the Earth cooled, the water vapor condensed. If you were asked about this, you'd need to use the words cooled and condensed. So all of that water vapor that was present would have cooled, condensed, and formed oceans. Once those oceans were formed, the carbon dioxide that was in the atmosphere dissolved in the oceans, and that massively reduced the amount of carbon dioxide in the atmosphere. As well, we have now got oxygen in the modern atmosphere. Because you then had water on Earth, Earth could support life, and organisms, which are living things, a lot of organisms can carry out photosynthesis. So things like plants, but also some types of bacteria carry out photosynthesis. And to carry out photosynthesis, when you carry out photosynthesis, you will produce oxygen. So the presence or the emergence of living things on Earth meant there was an increase in oxygen because plants and a lot of species of bacteria carry out photosynthesis and produce oxygen. Photosynthesis would also contribute to the removal of CO2 from the atmosphere as you use carbon dioxide for photosynthesis. So these are the key points that you need to know about what the Earth was like and why the atmosphere was like that, and then how things changed. The main thing, the Earth cooled, water vapor condensed, that removed the water vapor from the atmosphere, but it also, the carbon dioxide was able to dissolve in the oceans and it massively reduced the CO2. The other thing then, organisms carrying out photosynthesis, and that's going to produce oxygen. Sticking with oxygen for a moment, you need to know the test for oxygen gas, okay? So we've seen lots of gas tests throughout the course. If you're asked to test for hydrogen gas, you would say a lit splint gives you a squeaky pop. If you were asked to test for carbon dioxide, you would say lime water turns milky. If you were asked to test for chlorine gas, you would say damp blue litmus paper turns red, then bleaches white. And this is the fourth gas test that you need to know. Test for oxygen gas, and a glowing splint will relight. So we're clear on a splint. The splint are just those little pieces of wood that we use to light the Bunsen burner. And by glowing splint, I mean that the splint had been on fire and then the fire had been put out, but it was still hot and it's still glowing. So you've had a splint that was on fire, but you put the fire out, but it's still glowing. If you insert a glowing splint into pure oxygen, it will cause the splint to relight. So when you're talking about hydrogen gas, it's a lit splint. It's a splint that's actually on fire. When you're talking about the oxygen gas, it's a glowing splint. A splint that was on fire, you've put it out, it's just glowing, but that glowing splint will relight in oxygen gas. The other thing you can be asked about oxygen is they can describe experiments that are used to determine the percentage of oxygen in air. And in these experiments, when they talk about the percentage of oxygen in air, they will give you the volume of air at the start. So for example, 200 centimeters cubed. So centimeters cubed are just the unit for volume. So they'll give you the start volume of air and an end volume of air. And the first thing you're going to do is just calculate that change. So I started with 200, ended with 160. The change in volume is going to be 40 centimeters cubed. Once you've got that change, what you'll need to do is calculate a percentage, and you'll take your 40 centimetres and you will get it as a percentage of your starting volume. Here we see our starting volume is 200, so I'm going to take 40, which is my change, divided by the starting volume, which is 200, and then multiply that by 100 to get it as a percentage, and you'll see that the answer works out as being 20%. Okay, so you're calculating the percentage of oxygen in air, and it should work out as roughly 20%. So calculate the change in volume, then you take your change, put it over the initial volume, multiply by 100, and you'll calculate the percentage of oxygen in air.